Hello everyone. In this video, I will talk about an electric ball valve and discuss the normally open model. For example, you might need a valve that is constantly open, and when power is supplied to it, it will close. This particular model is normally closed. It opens when power is supplied, but you need a valve that works the opposite way. For example, such a valve could be used in a water leak protection system, meaning when a sensor triggers an overflow, the valve closes. Power is supplied to it, and it closes. When power is removed, it automatically opens. You can order such a valve using the link in the description. That is, you follow the link, select the desired model, and choose the normally open one. Alternatively, you can make such a valve from this one. This is model CR04, which is normally closed. And now I will show you how to modify it so that it works the opposite way, meaning it would be constantly open and close when power is supplied. First, we will remove the top cover of the electric actuator. Unscrewed. Here we have the circuit board. It also needs to be removed. So we unscrew two screws here. One and the second. They are of different lengths. The longer one goes near the relay because the hole here is deeper. Okay, we've unscrewed that. Next, we'll need to unscrew the gearbox. We unscrew these two screws. The second one, unscrewed. We remove the gearbox with the motor. The limit switch has disconnected, and there's a power reserve here. These are capacitors. They still hold a charge, so it rotates. We will need to swap these two limit switches that turn off the motor. We remove one, we remove the second. And swap them. We insert one here. We insert the second one here. Swap them, and now we assemble it back. We insert the gearbox. We make sure that the wires don't get caught anywhere, don't snag, so as not to damage them. We screw the gearbox back in. Screwed in. Now on the circuit board, these two wires come from the motor and lead out. So the motor is powered from here, it rotates. We will need to desolder them and swap their positions, plus and minus, to change their places, to change the direction of the valve's rotation. Because it will still always open when power is supplied, but since we swap the limit switches, it won't turn off. So we desolder the two wires and solder them back. Just we swap them, one and the second. And now we assemble everything in reverse order. This plastic spacer, we put it back so that nothing shorts on the board. We can twist the wires just like they were and put them in here. There's space there, and we screw the control board back in. A short screw goes here. A long screw goes here. Also, make sure the wires don't get under this cover. We screw it in, but I'll just loosely fasten it now and tighten it later to save time. That's it, done. Now we need to supply power to the valve. Since there's no charge, it remained closed and couldn't open. We connect the power. The valve closed. We remove the power. The valve opens. This is the normal position of our valve, meaning it's always open. If you supply power to it, this model operates on 9 to 24 volts. That is from 9 to 24. We supply power. I currently have 12 volts, and the valve starts to close. It closed. We remove the power. The valve opened. This is how this model now works. It turned out to be normally open. I'll leave a link to the same model in the description. You can order it. If you can't find a normally open one, you can simply make it from a normally closed valve like this. Thanks everyone for watching. Bye everyone.